From WAMU 88.5 at American University and broadcasting live from National Geographic's headquarters, welcome to the Kojo Namdi Show, connecting your neighborhood with the world. Today we're exploring the future of the past. In bygone eras, explorers set off on years-long expeditions to sites in far-flung remote corners of the world, spots where they climbed, dug, dusted, or dove looking for signs of ancient civilizations, long-lost ships, finding priceless artifacts, abandoned towns, and often enough, nothing at all. Today's archaeologists and oceanographers use new digital tools, including satellite images, sonar, and remote-controlled vehicles to locate and explore new sites, often without ever having to turn a spade or plunge into the sea. Here to tell us about the innovative tools they're using and what they're finding with them is Sarah Parcak. She is a professor of anthropology at the University of Alabama at Birmingham. Sarah, thank you for joining us.
Thank you very much for having me.
Also here with us is Fredrik Hiebert. Fred is an archaeologist who holds positions at the University of Pennsylvania Museum of Archaeology and Anthropology and the Institute for Nautical Archaeology. Fred Hiebert, thank you for joining us.
Thank you very much.
And Katy Croff is an oceanographer and vice president of the Ocean Exploration Trust and chief scientist of the Nautilus Exploration Program. Katy, thank you for joining us.
It's a pleasure to be here.
These are all National Geographic Emerging Explorers or Fellows and Futurists with the Future of Information Alliance at the University of Maryland. By the way, if you'd like to join the conversation by phone, give us a call at 800-433-8850. What is your impression of the work contemporary explorers do? You can send us email to kojo@wamu.org or shoot us a tweet at Kojo Show. Fred, I'll start with you. Each of you works in a field that lots of kids dream about pursuing. What inspired you to study this area of expertise?
Well, I'm your sort of outside guy who came into the field backwards, I suppose. I actually went to school to be an artist. And I had this great dream to go to Paris and become an artist and work in a studio there. And my parents were crazy enough to let me do that when I was 18 years old. So I took my etchings and I went to Paris and I said, I want to work in an art studio. And of course they laughed at me. That's not how you do that. You have to pay to work in one of those Parisian
No, they just laughed at you again. Go ahead.
Yeah, but they took pity on me and they said, well, you know how to draw. Why don't you go to the university and work for the archaeologists? And I thought that was kind of strange, and I went there, and I must say I fell in love with it. And I had the chance to go into the field with them and be a field artist. And I became an archaeologist, and I came home, and I apologized to my parents. I said, I guess I'm going to go to college now.
What a great story. Katy, how did it work out for you?
Well, it was, I sort of fell into it as well. I grew up in San Diego, spent tons of time on the beach, on the water as much as I could, loved math and science, went off to college and studied ocean engineering, and got an email during my junior year about an expedition to the Black Sea to look for shipwrecks with Bob Ballard. And so naturally I raised my hand and was one of just a couple of students that got to do that and absolutely fell in love with it. And then after that went on and got my master's in archaeology.
The rest, as they say, is history.
That's right.
And now your turn, Sarah.
Well, so I grew up in Bangor, Maine, where there are no pyramids, by the way, and but I've always been in love with Egypt. And when I lost my first tooth, the tooth fairy brought me a wonderful history of ancient Egypt that I still have and treasure. But you know, like life went on, and I got involved in politics in high school. But I still had this love of Egypt. And I remember I was about to get on the bus to go to Yale, and I turned to my mom and I said, "Mom, what if I end up majoring in Egyptology?" And she said, "Don't worry, dear, we're going to support you no matter what." So I was very lucky to have some incredible professors. And my senior year, I took a remote sensing course because of my grandfather, who was a specialist in using aerial photography for forestry. He was a forestry professor at the University of Maine. So I've been in love with Egyptology ever since I was a small girl, but I had absolutely no idea that I would get involved with remote sensing. So fell into that as well.
Most of us got a quarter when we lost our first tooth. Fred, you helped to pioneer the field of exploring land and sea jointly. Why had it not been done much before, and what inspired you to do so?
Well, it is a great opportunity to do projects with National Geographic where they really hope that you do something completely out of the box. And I grew up sort of walking fields in Michigan and Ohio, and I ended up walking fields in Arabia and across the Silk Road. And so that's what we do, is we walk a lot of fields. We walk transects, straight lines. And I realized that it's really hard to walk transects underwater. All right, so, you know, the divers go in, and it's usually very opportunistic. It's like they find something, and it's like, oh, go there, it's a shipwreck, right? But technology really started to change in the 1990s, and the ability to actually tow sonars that could do straight lines underwater made it possible for the first time to have a single strategy where you walk fields, and then you sort of walk straight into the water with these sonars. It was very cool. It was kind of interesting to see the lines as you go from land. And I remember I would take my crew on land, and we would walk right up to the bluff, and I'd say, please don't go any further. And then there would be a boat, and then we'd continue going out. And we actually created maps underwater. And if you would sort of like magically take the water away, you'd get this landscape. In some cases, it had been dry land in the past. In other cases, it was places where you could actually see the trade routes of ancient ships, because you could see a line of boats. And so it really opened up this idea that systematic research on land and underwater, really, it's just two sides of the same coin. So it was a lot of fun.
In case you're just joining us, this is a conversation about the future of the past. We're talking about new frontiers and exploration, and inviting you to join the conversation by calling 800-433-8850. We're coming to you from the headquarters of the National Geographic Society, where we have an audience here in studio. What areas of the Earth do you think we've only scratched the surface of when it comes to understanding? Give us a call. 800-433-8850. Sarah Parcak, it sounds futuristic, but it's what you're doing now. What exactly is space or satellite archaeology?
So, you know, traditional archaeology involves going out and excavating sites, and there are so many stories we hear of archaeologists going and digging for an entire season and potentially not finding anything. So this field has been around for about 30 years, and it involves the use of air or spaceborne sensors to map and detect previously unknown archaeological sites and features. And this is a great tool because, you know, as archaeologists, we think we know our sites really well. We walk over them every day. But it's when you pull back into space and you get, you know, a completely different view and appreciation for literally what's beneath your feet. And what's amazing about satellites is that, first of all, it gives you this air-based perspective, but also using infrared, near-infrared, and thermal sensors, it allows you to see things that are literally invisible to the human eye on the ground, which allows you to find hidden tombs or pyramids or settlements or even entire cities beneath rainforests.
Well, prove it, because here in the Grosvenor Auditorium, we've been looking at an image that's pretty clearly of pyramids taken from far above. Now tell us what you see in this second image that the rest of us might be missing.
Sure. So what you see on the screen in front of you is a processed satellite image of a pretty well-known ancient Egyptian site. It's called Gurab. And what you're looking at is actually the harem town of the New Kingdom pharaohs. So this site dates to about 1500 BC. It's where many of the great kings of Egypt's New Kingdom would have grown up. It's about 2 hours south of Cairo, close to the entrance of the Fayum. And when you're walking over this site, it's in the desert, and you can't see anything. And what you're seeing on the bottom part of the site is the palace part of Gurab, which is pretty well known. But the area to the north is virtually unknown and unmapped by archaeologists. And it's by processing the satellite data that you begin to see these very subtle differences by buried objects, so mud, brick, and stone, that start to pop out. So what was previously a completely blank map, all of a sudden, from 400 miles in space and from thousands of miles away, you're actually able to see the outline of an entire city.
And for those of you listening outside the Grosvenor Auditorium, you can go to our website, kojoshow.org. There you'll find a slideshow of the images we're talking about, the Gurab process slide that we are currently looking at is one of those images you can find there. That's at our website, kojoshow.org. Katy, you recently got back from a voyage that provided a really good example of how a day expected to quite literally be spent mucking around in the muck.
That's right.
Can turn up unexpected discoveries. Where were you and what did you find?
Well, we've been exploring in the Gulf of Mexico and Caribbean Sea for the past 6 months or so. And the very last cruise was off the coast of Grenada, exploring the only active underwater volcano in the Caribbean called Kikum-Jenny. Now, Kikum-Jenny is actually a small volcano that's grown up inside a much larger, older one that at some point in time probably erupted and caused an underwater landslide. So a whole lot of sediment and rock had moved down the slope. And so one of the last dives of the cruise, we were going to take a look at that landslide deposit to see if we could collect some samples, get a little bit more about the history. And we really thought that it was just going to be a muddy, boring dive. We actually had a National Geographic film crew on board prior to that dive, and we said, Jen, don't worry about it. It's going to be boring. You're not going to miss anything. Unfortunately for her, we did find something. We found this unbelievable ecosystem growing at the toe. It's called the toe, the furthest out part of the landslide, where probably methane is being squeezed out of the seafloor because of that huge load of sediment and rocks that had been deposited on the seafloor. It's right off the coast of Venezuela, the Orinoco River. And so you have a very high concentration of organic material that now is getting squeezed up out of the seafloor, and you have chemosynthetic mussels. These mussels are 14 inches long, so they're gigantic. And inside, almost every one was this huge red scale worm that looked like it had blood coming out of it. It was really kind of gross and awesome at the same time. But it's really incredible to discover this, because we all thought that all these landslides all over the world are just, muddy and boring and not too exciting. But it shows that all over the world we might have these areas where carbon, this methane, is coming up out of the seafloor and creating these ecosystems. So it really has the potential for further study all over the globe.
And you thought you'd be just mucking around in muck all day long.
Exactly.
In an age when anyone with an internet connection can get an answer to a question online in a fraction of a second, some might think that we know it all, that we left no corner of the earth uncharted, undiscovered, or understood. That's the perception anyway. What's the reality, Fred?
Well, the reality is that we're in a kind of unique field, archaeology. I think it's one of the few professions where our entire goal is to make our textbooks go out of date, right? Everything that's written, we challenge. And so you have to imagine, in an age where the internet is everywhere, there's jet transportation, truck transportation, and cell phone towers in the middle of Mongolia, you think, okay, we know everything, right? The thing that's so interesting about going and actually discovering something in one of these places is that rather than answering a question, maybe we do answer a question, we come up with 10 new questions. That, for me, is so exciting. It's sort of like, yep, my textbook was wrong. Well, it gives me a job, but, but at the same time, it just means that we're scratching the surface of the world, that we're just beginning to learn about who we are and where we're from, and all these ideas. I grew up with the 5 centers of civilization as the model that we were taught in school. It's like, whoa, no way. I go work on the Silk Road, and I find civilization in bunches of other places, and it's sort of like, explain that, textbooks, right? So I think really that's what we do. It's like we create questions.
Sarah, is it really that the more we know, we just find out how much we really still don't know?
I agree completely with what Fred said. So, if you look at the field of Egyptology, and this is an incredibly rich field that has been around for over 200 years, and we think we know everything. We think we know about pyramids and temples and pharaohs. And I often get asked the question, well, just how much of ancient Egypt have we found? And it's like, okay, well, how long is a piece of string? How can you really say? But actually, I sat down one day and looked at, actually it took me about a month, I looked at all the known evidence of excavations in the Egyptian Delta alone, and kind of figured out what percentage of each site had been excavated. And I figured in the Delta alone, we've excavated 1/1000th of 1% of all the sites and their total area. And if you add on top of that all of the sites all over Egypt. So my team and I have been able to map over 3,000 previously unknown sites all over Egypt. And you think that southern Egypt is less well excavated. We only know a tiny fraction of a tiny percent of ancient Egypt. That's in Egypt, one of the most well-known ancient civilizations in the world. What else is out there waiting to be found? I think there are hundreds of thousands of sites all over the world waiting to be found. So for the kids that are in the audience and tuning in, there's a lot of work for you to do.
Katy, same question to you.
There's certainly a lot of work to do in oceanography. There's no doubt about it. I mean, 3/4 of the planet is covered by water, and we've just barely scratched the surface. In terms of understanding our home planet, really, it's not just about the archaeology and the history, but it's also about the geology, the biology, the chemistry. How are we impacting the oceans? How do they impact us? And how does our home work? And there's still tons and tons of work to do.
It's very exciting to know that there's so much more to learn. On the other hand, finding out that we're much more ignorant than we thought we were about what's going on in the world is not that exciting. But we're going to take a short break. When we come back, and while we're on that break, you can still call us at 800-433-8850. We're coming to you from the headquarters of the National Geographic Society. You can send us email to kojo@wamu.org, and we have a studio audience here that will soon be lining up at microphones to ask questions or make comments to our panelists. But the number is 800-433-8850. I'm Kojo Nnamdi. That's the house band. Yes, feel free to approach the microphones at any point if you have a question or comment. We like being interrupted. It's not a problem. Welcome back. We're coming to you from the Grosvenor Auditorium at National Geographic Society headquarters with a discussion on new frontiers in exploration. We're looking at the future of the past with Fredrik Hiebert. He is an archaeologist. He holds positions at the University of Pennsylvania Museum of Archaeology and Anthropology and the Institute for Nautical Archaeology. Katy Croft-Bell is an oceanographer and vice president of the Ocean Exploration Trust and chief scientist of the Nautilus Exploration Program. And Sarah Parcak is a professor of anthropology at the University of Alabama at Birmingham. You can call us at 800-433-8850, or you can go to our website, kojoshow.org, take a look at our slideshow, or ask a question or make a comment there. We have a studio audience here in the Grosvenor Auditorium with an individual who has a question. Yes, sir.
For National Geographic, I have 3 quick questions that I call an astronomer's lament over inspiring all those explorers currently in grades K through 12. First, how can I inspire them when your gift catalog sells telescopes and accessories astronomical that are low quality and so overpriced? 2, how can I educate them when your latest story on the Mars rover Curiosity uses only the measurement units of long dead English tyrants, like miles, pounds, and Fahrenheit, instead of the measurement units of cosmic discovery, like kilometers, kilograms, Celsius, and Kelvin? And finally, how can I tell girls in grades K through 12 that they too can reach for the stars literally when your latest cover story on third millennium interstellar travel is riddled with those tired, old, second millennium misogynistic terms, manned and unmanned?
We have an answer for that lament. And it was a brilliant lament. Each of our panelists teaches in one way or another, and while I'm sure that the students walk away wiser for the experience, I imagine you often do as well. Tell us a little bit about your teaching experiences and how does that experience inform what you do? What is your response to the lament?
Well, I'm one of the unusual, I suppose, lucky people who's had an experience teaching at a university and then sort of teaching through the pages of National Geographic. One wonders how one could possibly morph from teaching at a research institute to going to National Geographic, which has big media reach around the world. Well, I like to think that my classrooms of 10 and 20 students that I have been slightly enlarged by having audiences of 1 million or 3 million or 10 million or 40 million people as we do with our television reach. And I like to think that we meet and greet every single one of those 40 million students out there, and we do everything tailored to what they do. We teach to the broadest possible audience at National Geographic. That's a huge challenge. For sure we make mistakes, for sure we don't address everybody's detailed interest. But the fact is that we impact people around the world, people who don't have access to textbooks, people who don't have access to go to museums. This is really our greatest educational business at National Geographic. We really care about the world. We really care about the planet. We would love to teach to every single level possible in the world, but we think we are doing our best job by getting the message of science and excitement about life to the broadest possible public.
Sarah.
So I guess like Fred, I wear different hats. I'm a professor, so I spend a lot of my time teaching, but I've also had the chance to do some television work, and certainly here at National Geographic, I'm very excited about all the public outreach opportunities that I'm going to have. I am of the Indiana Jones generation. This is he's one of the reasons why I got interested in archaeology, as did so many of my colleagues. I think one of the problems that we're facing now in science, especially for young women, is there simply aren't enough people that look like little girls. In other words, they want to look up and see people that look like them. They want to see young women who are being passionate about what they're doing, who are willing to take risks, because we know how many problems we have with our educational system. And I didn't really realize the impact that I could personally have on kids. And I remember last summer I got a letter from a family in England, and it was a hand-drawn picture of several pyramids. One of the kids had drawn a picture of me, and I was next to her. And her mom had written me and told me that because the girl had seen a program that I was in on TV, she now wanted to be an Egyptologist. And then they wanted to share that with me. So of course I wrote back, and I realized at that moment, I guess the mantle of responsibility that we have to reach out not just to kids or girls, but to all kids. We're facing so many problems with getting kids involved in STEM disciplines. So I call archaeology the gateway drug to science. Through studying archaeology, I tell my students, if you want to be an archaeologist, study science, study biology, study physics, study chemistry, study computing, because this is the future of exploration in archaeology. So I believe very strongly that it's my job, not just in the classroom, but all over the world.
Katy.
Well, unlike Fred and Sarah, I'm not a university professor. I don't lecture in the classroom, but and my 7th grade teacher thought told me that I was going to be a math teacher, and I'm not. But I do like to think that I teach all over the world, a very global audience. During our expeditions, we have a satellite telepresence system on our ship that sends live video, data, and audio of all the scientists, engineers, and students, educators who are on board the expedition. And you can watch that, you can hear that on your own laptop, computer, iPad, whatever, at home. We have hundreds of thousands of people all over the world watching, and we take that responsibility very, very seriously, particularly in the Department of Role Modeling for young women, underrepresented minorities, in particular ocean science and engineering, but in all STEM fields, because it is a large problem in the world, and in particular in our own country. And so a large part of what we do is not only allowing people to see us and to listen to us while we're exploring, but also interacting with that audience. And so you can write in questions, we get them a split second later, and we're able to answer them, and you can hear everybody's story on the ship. You know, so many kids write in and ask, how can I be like you? And that gives us the opportunity to say, well, we studied this in school, or I enlisted and am now an electrical engineer, and I'm a remotely operated vehicle pilot, or I went all the way through and now have my PhD. Whatever the story is, we really enjoy sharing that and making sure that people, like Sarah mentioned, can see, and not just people, but in particular kids, can see their own face 20 years out, so that they can know and understand that a career like that in math, science, engineering is possible for anyone.
Thank you very much. Sally, lady at the microphone.
Thank you, Kojo. Sarah mentioned that you have such a small percentage of archaeological sites that you've been actually able to dig and explore. And given the fact that the Earth is 3/4 water and primarily ocean, that must be many times more in terms of how much you've been able to explore. So my question is to Katy. What is that percentage? And you must be hampered by other things, such as the depths that you have to go to really find what you're looking for, or what might be there, because of the technology that's not quite there. So my question is, how much more do you think needs to be explored, and how does technology, how is it improving to help you do your work better?
If I may add to that, because I happen to know the question of Sally Foreman, if I may add to that, can you talk a little bit about what technology has allowed you to do recently that you weren't able to do even maybe 5 years ago?
Sure. Well, the first sort of step to finding an archaeological site underwater is similar to Sarah looking at the satellite images of the land. It's creating a map of the seafloor, and we do that with sonar. So you send out pings of sound that travel through the water, bounce off the seafloor, and come back to your instrument, so you're able to both get a shape of the seafloor, but also a relative measure of density. So is something hard or not? And so using that, you can get an idea for what you're looking at. Is it a rock or a shipwreck or an airplane, a submarine, whatever's down there, a refrigerator. We've found those before. So the first thing you do, is you make a map. But oftentimes with a sonar, you aren't able to actually hone it down to what actually is that thing, that lump on the bathymetric map. So then you put in your remotely operated vehicle. So this is your eyeball that goes down underwater, and you're absolutely right. It's dark, it's cold, there's high pressure, and it's deep. So there are huge challenges with working underwater, and that's the fundamental reason why we haven't done it and we haven't explored the oceans, is because it's just really hard to get down there and it's very expensive to do. So this image you're seeing is Little Hercules. It's a remotely operated vehicle that we use to image the seafloor, image shipwrecks, and start to get an idea for what's down there. And then sort of the next step, once we find a site, whether it's a shipwreck or an underwater volcano or that cold seep site with the Star Trek worms, the next step is you are trying to digitize the seafloor. So we have a suite of sensors on sort of companion vehicle, big Hercules, that allows us to create very, very accurate maps, sub-centimeter resolution of these sites, and it gives scientists a much better perspective of what we're seeing, because oftentimes you can, barely see your hand out in front of you underwater, and so you have to be able to put these images together, put the sonar data together to actually recreate the seafloor in a way that we can comprehend.
If you're wondering what we're seeing, you can also go to our website, kojoshow.org, and you will see the slideshow there. I don't know if Fred wants to add anything to the description of what we're seeing.
Well, I'd just like to add, it's wonderful to be here in Washington because you guys know about the known unknowns and the unknown unknowns.
We've known about them for several years.
For several years, yeah. And I wish I was a Washington politician because they seem to know what the unknown unknowns are, but we don't. So, the future of exploration is a lot of going out and trying to make the unknown unknowns into known unknowns, and then we have something actually that we might know about if we don't know about it now, and maybe we'll know about it.
And there's so many times when you go out, you're looking for one thing. We were exploring underwater volcanoes off the coast of Sicily a couple of years ago, and we're cruising along. It's Halloween, 2011. Looking for these underwater volcanoes. We had somebody tuned in, writing into us, "Hey guys, how's it going? What have you found? Have you found any World War II airplanes?" And we said, "Well, no, we've never found a World War II airplane." Not 10 seconds later, did we come across that Italian airplane from the Battle of Pantelleria in 1942, just in the Straits of Sicily. It was incredible. So the unknown unknowns, we didn't know it was there. But the really incredible thing, aside from just the coincidence of it, was that there are people watching on Pantelleria, this very small island near Sicily, and they were telling us what it was. We had no idea. None of us are plane historians, and so we could see an insignia on the wing, so we knew that it was Italian or from the fascist party. But they said, "Oh yeah, that's a Mach-E C-202. It probably went down in this battle. We don't know if there were 2 or 3 planes lost." So we sent off all the data to the Department of Antiquities in Sicily, and so they can then move forward with whatever they want to do to follow up and study it. So yeah, there's just so much down there that we don't even know exists.
Mike in Arlington, Virginia had a question about this. I don't know if you've answered it yet. Mike, are you there?
Yes, I am.
Has your question been answered?
No, actually, I'd like to follow up on it, and thank you for taking my call.
You're welcome.
Very interesting, and I have to say I was fascinated by this whole project that, Katy, you mentioned got you involved in this, the Black Sea Project with Robert Ballard. Can you please tell us a little bit more about what you found there, and what ongoing work is being done there, please?
Sure. Actually, Fred can probably follow up as well, as he was on my first oceanographic expedition ever, which is very exciting.
Really sand archaeologist, right?
Well, the first cruise was in '99, and we've had several follow-up cruises, and there are actually 2 parts of it. I'll let Fred talk about the Neolithic part, but I can talk about the shipwrecks. So the idea was that below about 150 meters, or 450, 500 feet, if you want to put it in the archaic, tyrannical terms, there's no oxygen in the water. So the hypothesis that had been posed in the 70s was that if there's no oxygen, then the animals that require oxygen to live and that eat wood and other organic material won't be there, and so you'll find well-preserved shipwrecks in the Black Sea. And that is absolutely the case. The first one we found was in 2000. It was about 1,500 years old, had a mast still standing about 12 meters high, with rope tied around the top of it. Absolutely incredible. And so we've been continuing to go to the Black Sea every year, every other year or so, and are looking for really as many wrecks as we possibly can so that we can try and start connecting the dots with the trade routes. You can't make a line with one point. So we're trying to be able to cast a very wide net, cover as much seafloor as we possibly can, and start to connect those dots between ports, between people, communication between people.
Well, let me just add that I had the great luck of having Bob Ballard and Katy off the coast where I was walking transects in Turkey, and we were finding all this pattern of ports and trade sites that were there. And oh boy, wasn't that great to see this great research vessel out there. And that's the vessel, that big research boat that Bob Ballard had, and he had all these scientists who never got wet because they were looking at everything with sonar. They're the ones who made a map of the bottom of the sea for the first time off the coast of our ports. And I'd say, well, you know, here's a port, here's a road, here's a mountain, and stuff like that. And what he basically did, he created a map off the coast of Turkey in the Black Sea, in this area where under 200 meters it's like anoxic, there's no oxygen and everything's mysterious and we don't know what the bottom is. And we found an ancient coastline. Now, how cool is that? Underwater. And for me, being a land archaeologist on the boat, it was sort of like, oh, wow. If I was on land, if I was sending my team to walk along the coast, where would I go? Would I go along the coast, or would I go up in the mountains? No, of course not. We always found the sites right in those valleys that had a good view of the ocean, of the Black Sea. Now, what if the Black Sea had been lower? And we knew that about 7,500 years ago, it was much lower. So we started to look for that submerged landscape. And we found valleys, and we found rivers, and we found evidence for things that looked like houses or villages. We're realizing we're on the verge of something big, because if this is really a submerged landscape, it probably came from what the geologists called one of the world's largest infillings, i.e. that's a flood, in the world. So just think about it. And there are places that we can't go on that. But you know, the world's largest flood that we have mythologically is Noah's flood. So that became part of the research project. Now, those questions are still open. And that's what I love about archaeology, is that we don't answer the questions.
Well, thank you very much.
Job security.
One of the known knowns is that we have to take a short break right now. So if you have calls, stay on the line. We will get to your calls. If you're standing here at a microphone, we will get to you. But we do have to take that short break. The number is 800-433-8850. When we come back, we'll continue our discussion on new frontiers and exploration. I'm Kojo Namdi. Welcome back from the Grosvenor Auditorium at the National Geographic Society. We're talking about new frontiers in exploration with Sarah Parcak. She's a professor of anthropology at the University of Alabama at Birmingham. Fredrik Hiebert is an archaeologist. He holds positions at the University of Pennsylvania Museum of Archaeology and Anthropology and the Institute for Nautical Archaeology. Katy Croff Bell is an oceanographer and vice president of the Ocean Exploration Trust and chief scientist of the Nautilus Exploration Program. Sarah Parcak, a lot of the tech tools developed in the last few years probably allow you also to do things people in your field could not have dreamt of a generation ago. How do you keep up with that kind of rapid change?
Well, it's something that I spend a lot of time thinking about. If you look at the history of remote sensing and archaeology, 30 years ago, satellites had a resolution of 60 meters or 180 feet. Now we have satellites with a pixel resolution. It means you can zoom in from hundreds of miles in space and see objects as small as 1.5 feet across. Next year, the resolution is going to improve to 1 foot. So if you look at this rate of change over time, it's not going to be that long before we can zoom in from space and see a single potsherd. And we're trying to catch up constantly with the advances in technology, with big data and with new computer programs. So this is what makes my job fun, because I feel like I'm never stuck doing one thing. I'm always getting to experiment with data and try new things and really take a lot of risks, because of course there's a lot of failure associated with good science, which is so important. So it's what makes my job fun. I love the challenge.
Thank you very much. On to you, sir.
In the span of human civilization timeline, at what point is it stopped being ancient? Like, is it by 1800s, 1900s, we kind of know where all the civilizations are, or is it constantly ongoing? And with that, is it going to be 5,000 years from now, if there's still human existence on the planet, we're going to be digging up Kojo Namdi signs underneath the water in DC? I'll hang up and listen.
Sarah.
Right.
One of you is going to have to take the ancient question.
All right. Well, I will admit fully that for me, ancient stops at around 0. I like ancient Egypt a lot. Probably I'd say 500 AD. But this is a big debate, right? When does the ancient world stop, and where does the modern world begin? And of course, historical archaeology is an incredible field, and people are now excavating sites from 50 years ago or 100 years ago. So yeah, that is very much a tricky question. I think it depends on the archaeologist that you ask.
Well, I remember when I was a teenager, whenever my friends came to visit me, they would always say, "Are the ancient ones at home?" Meaning my parents.
Yeah.
So you never know. You are next, ma'am.
I've never been out of the country, so I really don't know what's out there. And what has been your favorite adventure, and what is your favorite thing that you've found?
What is your absolute favorite thing that you've found? Well, we know that Fred's found a coastline, but apart from that, what's your favorite thing that you found? Katy?
Well, I don't know. We found a lot of things. Today, that seep
Today,
is
she
the
found her way
favorite
to
thing.
this broadcast.
I made it to this table. No, I mean, traveling around, going on all of these expeditions, really the most amazing things about it is that I do have the ability to do that and meet so many amazing people, scientists, students, engineers, all over the world. Prior to working in the Caribbean this year, I've spent a lot of time in the Mediterranean, the Black Sea, and getting to know and meet new people, be exposed to new cultures, and explore the places just offshore and sharing with the people that live there. When we're working in Greece, we have Greek scientists on board, and they're able to answer all the questions that we're getting into the website in Greek to their own students and public. So it's really an incredible way to be able to share everything that we're doing with people all over the world. And so I don't know about my greatest adventure, but I think that one of the greatest aspects of my work is being able to go to these places and work with new people and share with many people all over the globe.
Fred, technology has not only allowed the discovery of new sites, but it can help preserve known ones, especially in areas that are in turmoil. How are you using these tools to keep an eye on the problem of looting?
This is a big issue that's coming up, and as the world becomes more global and we have access to different parts of the world, we actually become more connected with areas that are disrupted and in conflict. It's part of the seriousness of the 21st century. Is a conflict in Egypt or Afghanistan or issues around in other countries affects all of us. So we archaeologists, we have to kind of become crusaders because the past is an irreplaceable resource, right? It's not like a tree that gets cut down and you can plant another tree. We have to go out there. And so we're working on a project through National Geographic, which is actually quite proactive. And my favorite way of sort of helping protect resources that belong in a certain country but end up in peril is by shedding a light on them, putting a spotlight on them, inventorying them, get a photograph of them, get a satellite image of the site, seeing if we can document it to show that that's where it really should be and it should belong there. And that would be my dream, is to make like an inventory of the entire world. But I don't think we can do that.
Working on it one item at a time. Yes, sir.
Thanks. So obviously this technology is changing the field of archaeology quite a lot. But do you think in 30 or 50 years there will still be a place for that sort of Indiana Jones mentality?
Good question.
It's a great question. I would say yes. So next year there's a brand new satellite being launched called WorldView 3, and this is the satellite that's going to give us a resolution of about 1 foot. And instead of just being able to see in the near infrared part of the light spectrum, we're going to be able to see in the middle infrared, which is going to allow us to map all of these incredible geological changes to the Earth's surface. So that's next year. If you had told me 10 years ago when I started doing this work what the satellites would be like, have been like today, I wouldn't have believed you. I can't even begin to imagine what satellites are going to be able to do from space in 50 years. Are we going to be able to zoom in and actually see under the ground? Who knows? Who knows? And it's up to you. It's up to the kids in the audience and the kids that are listening to innovate, to invent, to create, so that we can have these incredible views of the past from space. Because 50 years ago, if you had told my colleagues, Egyptologists that were working at the time, that there were simply thousands upon thousands of unknown sites and unknown pyramids and settlements in Egypt, would they have believed you? I don't know. So, for me as a scientist and someone who tries to think about what is there that I'm not finding, I'm not able to see beneath the floodplains, I'm not finding everything right now because the technology isn't there yet. I think that if I were to write a textbook today, my greatest hope is that every single thing I write is wrong.
And on to you, ma'am.
So my question is very related to that last answer. You've talked a lot about how today you're able to do things that you never imagined you'd be able to do. Think about 2 years, 5 years, 15 years, 20 years into the future. And if you could write a shopping list for the things that you would be able to do, what would they be? And what do the students and the people who are working on these technologies right now, what do they need to be shooting for?
Katy.
Well, a couple of things. One would be higher bandwidth to be able to get more information off the ship and back to shore, to include more people, not just the public, but scientists as well. We, cast a wide net to as many scientists as we can to include them in the expeditions, but also being able to look at the seafloor more efficiently than we can today. That's one of the most limiting factors, is the fact that we're out there on a ship that's going 10 miles an hour, mowing the lawn back and forth, collecting this sonar data. So having autonomous vehicles, so these are basically underwater drones that you program and send overboard. And this technology has been in development for the past 20, 30 years or so, but it's still $1 million a vehicle. So making these more efficient, more cost effective, so that we can just get down there and explore more of the seafloor more efficiently and more effectively.
When you mention $1 million a vehicle, we got a tweet from Gage for Sarah, who says, which government-sponsored or commercial satellite programs do you use for exploration? Do funding cuts threaten your work?
They do. They do. There have been major funding cuts to the National Science Foundation, the NEH, any kind of government-funded organization. And I was recently in China for meetings with the Chinese Academy of Sciences, and their government is throwing billions and billions of dollars at science there. And it was just so inspiring to see, a government that was so invested in science. So I think, for our own government, the future of our country is going to be deeply rooted in science and technology and innovations. Nowhere in the world, I think, are people innovating better and inventing better and creating things that are going to have a significant impact on the future of our world. So for me personally, yeah, it's a huge challenge to get funding. It is for all of my scientific colleagues, so we try to be creative with fundraising, and I have to say National Geographic has been unbelievably supportive of my work, so I'm just very, very grateful to have their support.
We're running out of time. I'd like to make your question or comment brief, please.
I wanted to know how the flotsam and jetsam and the refuse of human activity interferes with the equipment that you work with in order for you to do your work.
Oh, fishing lines stuck on rocks and things floating up off the seafloor. It's very, very treacherous. And we do come across, fishing lines that got snagged on coral or rock or something. And so that is dangerous for our vehicles.
Anything you'd like to add to that, Fred?
Well, I'd just like to say, as an archaeologist, I love flotsam. That's basically the structure of what we go out and find, because every little piece that's out there, every candy bar wrapper that you eat and throw away, we can figure it out. It's very much like Sherlock Holmes. So, flotsam and jetsam, it's actually what we study. So I think it's great to have it.
It is fun to try and ID a Coke can or beer can or something from like 10 meters out.
Sarah, you get the last word. Do you think we'll ever find answers to all the questions we've got about the past and unexplored corners of the world? And would we even want to?
Well, I think what the past is showing us is, that we, with all these big questions, we have so much to learn about how we're living today. People in the past faced challenges regarding environmental change. People in the past made mother-in-law jokes. People in the past, they did. People in the past had jokes about everything and anything that were so connected. Our common humanity hasn't changed in thousands of years. So I think that's what the past has to teach us.
Sarah Parcak, she's a professor of anthropology at the University of Alabama at Birmingham. Fredrik Hiebert is an archaeologist who holds positions at the University of Pennsylvania Museum of Archaeology and Anthropology and the Institute for Nautical Archaeology. And Katy Croff Bell is an oceanographer and vice president of the Ocean Exploration Trust and chief scientist of the Nautilus Exploration Program. They are all National Geographic Emerging Explorers or Fellows and futurists with the Future of Information Alliance at the University of Maryland. Thank you all for joining us. Thank you all for listening. I'm Kojo Namdi.